Okay, so there are some concepts in grade 10 that you also need to know from grade 10 that you need to know for your grade 11 course. First of all, from the linear relations part of the course, you need to know finite differences. So understanding that first differences are constant makes the function linear. And if the second differences are constant, you know that that's quadratic. So we'll talk about that in a few minutes. But in terms of linear relations, you looked at finite differences. You also looked at solving systems of equations. So the three different methods you looked at are graphing, substitution, and elimination. We looked at elimination in the warm-up earlier. You're going to see some substitution and graphing in a second as well. So, for our examples looking at grade 10, linear relations, the first question asks us to solve the system of equations by substitution. And then the second question asks us to solve the system of equations by graphing. So let's look at the substitution one first. And for solving a system of equations by substitution, your goal is to isolate a variable in one equation and substitute it into the other. So you want to think about which equation it's easiest to isolate a variable and then which equation to substitute it into. So I'll notice that in the second equation, what you're looking for is the coefficients of x and y being 1 or -1. In the second equation, you'll notice that the coefficients are 1 for x and -1 for y. So it doesn't really matter which variable you isolate in the second equation. And remember that you have to substitute it into the other equation, the one that you haven't isolated in. So what I'm going to do is I'm going to isolate x in the second equation, and then we'll go from there. So isolate x in the second equation. So we'll get x equals. So as I isolate the variable, I have to move everything else to the other side of the equation, and so they will change signs. And so I'll add y to both sides to get y. I'll add 2 to both sides to get +2 on the right-hand side. Now I'm going to take this equation, I'm going to substitute it into the first equation. So I'm going to sub x equals y plus 2 into the first equation. And so what I get is 2 times y plus 2, so I'm replacing x with y plus 2, plus 3y minus 9 equals 0. And if I expand and simplify, I get 5y minus 5 equals 0. And remember that you're trying to solve for y, so move everything over to the other side. And you get 5y equals 5, which means y is equal to 1. Now, again, remember that in linear systems, solve means to find the point of intersection between the two lines. And so we've solved for the y-coordinate. We still need to solve for the x-coordinate. And so we're going to substitute back into one of the original equations. And the second equation is easier to use to isolate for x. So I'm going to sub y equals 1 into the second equation. And so I get x minus 1 minus 2 equals 0, which means x minus 3 equals 0, and so x is equal to 3. So there's the x-coordinate of the point of intersection. So therefore, the solution to the system is, remember to put your x-coordinate first and then your y-coordinate. So the solution to the system is 3 and 1. Don't forget to write it in point notation, so bracket the x-coordinate, comma, the y-coordinate, and then closing bracket after that. Okay, the second question asks us to solve the following system of equations by graphing. And so we need to graph both of these. You'll notice they're both linear equations. You'll also notice that they're in slope y-intercept form. So you should be able to figure out the slope and the y-intercept of each of these equations. So here I have a graph pad. And I'm just going to draw my axes, my x and my y axes. And I'm just going to use a scale of 1. So label your axes x and y. We're going to use a scale of 1. Okay, and so we're going to try to graph these two equations. They're both linear. You'll notice that the highest exponent is 1. That's how I know it's linear. So I have y equals 1x plus 1. This indicates to me that the slope is equal to 1 over 1. So that'll be my rise and my run. And this indicates to me that the y-intercept is equal to 1. So when you are graphing, the first thing you need to do is plot your y-intercept. and then use your slope as some more points. Okay, so we're going to use the y-intercept the slope to help us plot some more points. So from the y-intercept, we're going to rise 1, run 1, and create a new point. And I'm going to continue to rise 1, run 1, and create a bunch of points. And eventually you'll notice a pattern. You're going to use a pattern to help you create the line. Remember that your line needs to be very accurate, since you will be looking for a point of intersection between two lines. Okay, also remember to label your line, so that's y equals x plus 1, so that we know which line represents which equation that was given. Okay, second equation, we have y equals negative 1/2 x plus 4. Okay, again, the coefficient of x represents your slope. The number at the end represents your y-intercept. And so the slope in this case is negative 1/2. And so what that tells me is that I'm going to rise, or really I'm going to drop 1 because it's negative, and then you're going to run across 2. Okay, so start by plotting your y-intercept, which is 4, and then you're going to go down 1 across 2, down 1 across 2, down 1 across 2, and you'll already notice that the two lines have intersected. And again, don't forget to label this line. This is y equals negative 1/2 x plus 4, and you'll notice that the point of intersection is at 2 across and 3 up. So therefore, the solution to the system is 2, 3. So that was the point of intersection between the two lines, or in other words, a solution to the system. Okay, so the next thing we're going to look at is, again from grade 10, the quadratic relations unit. You looked at finite differences, so you know linear. The relation is linear if the first differences are constant, and you know it's quadratic if the second differences are constant. You also looked at how to graph quadratic relations that are in the form y equals a x minus h squared plus k. So some of the information you know from here is that the vertex of the quadratic relation, and in case you forgot what a quadratic relation looks like, it's just a U-shaped curve that either opens up or opens down. H and k help find the vertex of the quadratic relation, so either the minimum point or the maximum point, depending on which direction it opens. And so we looked at the step pattern last year to help us figure out how to graph a quadratic relation. So the first thing you did is you plotted the vertex at h and k, and then you used the step pattern and a to plot more points. So depending on what the coefficient here was, we were able to figure out what the step pattern is, so that we can graph the relation. Okay, so these were the regular step patterns. So we always went over 1 and then up 1, then back to the vertex, over 2 and then up 4. Then we went back to the vertex and we went over 3 and then up 9. But depending on the value of a, if the value of a was greater than 1, you know that the step pattern would increase. So these values here would change. And if it was less than 1, for example, even if it was negative, you know that the step pattern here would change as well. If the value of a was negative, instead of going up, we would end up going down instead. Okay, so those are some things to remember.